In this video, I'm going to go over how to solve exponential equations by using method number 1, which is common bases. In this method, we want to rewrite both sides of the equation so that they have the same base of the exponential, because when the bases are equal, then we know that the exponents must also be equal. So then we can use that property to solve. And these first two examples, I've got the work done for you already. So just to show you that in this example, if 5 to the 6th power equals 5 to the x, then we know x must equal 6. So that same thing is true over here, even when the exponents get a little bit more complicated. 7 to the 8th power is equal to 7 to the 3x minus 1 power. Well, if the bases are equal, if they're both 7, then that means I know the exponents are equal. Now, because these exponents are a little bit more involved, there are a few extra steps to finally solve for x. So that's why after this step, now I'm going to use some algebra to isolate the x. So adding 1 to both sides, dividing by 3, and we get that x equals 3. Now, of course, not all problems will be as easy as these two. A lot of times we're going to be given an equation where we have to first rewrite it so that they have a common base. So for example, this first one here, I have 9 to the 3x power equals 27 to the x plus 2 power. So my bases are 9 and 27. Well, those are not equal. So we need to rewrite them as some base to an exponent. If you think, okay, 9 squared is 81, so 9 is too big. What's another base that I could rewrite 9 and 27 as? Well, I know that 9 is really 3 squared. Could I rewrite 9 as 3 squared and then bring down the 3x? Yes. Well, can I also rewrite 27 as 3 to a power? 27 is 3 cubed. Bring down the x plus 2. So now I have the same base. Both of them are base 3. Okay, so now I can set the exponents equal. Now we do have two exponents here. We've got the 2 and the 3x, and then 3 and x plus 2. So if you remember the power to a power property from exponent properties, whenever we raise a power to another power, the rule is to multiply those powers. And I'm going to do that in my next step. So I'm going to bring down the exponents. 2 times 3x equals 3 times x plus 2. And now we're ready to solve. So the first thing I'll do is simplify both sides by multiplying. 2 times 3x is 6x. Here I'm going to have to distribute the 3. I get 3x plus 6. Next step, I'm going to get the x's together by subtracting 3x from both sides. And I get 3x equals 6. Last, divide by 3 to cancel out that 3. And I get x equals 2. Of course, you can always plug it back in to check your answer. But there's our final answer. Let's try another one. Here, I have 1/3 equals 3. Well, 1/3 and 3 are not the same number, but it is kind of close, right? They both have 3's. Think, how can I rewrite a fraction so that it's a whole number using exponents? If you remember the negative exponent property, that's the one that flips a fraction to a whole number. So 1/3 would be the same as writing 3 to the negative 1 power. Bring down the 2x. Now I have the same base. They're both base 3. So because their bases are the same, I can ignore the bases and set the exponents equal. Remember, we're multiplying here because we're raising a power to another power. All right, negative 1 times 2x is negative 2x. And now I'm going to continue to solve. So I'm going to subtract x from both sides, and I get negative 3x equals negative 9. Next, I'm going to divide by -3 so it cancels. I have to do that to both sides. And I get x equals +3. All right, if you're feeling confident, pause the video and try some of the next ones. If not, I'll do a few more with you. In A, I have 8x equals 4. All right, I need to rewrite them so it's the same base. What base could get 4 and 8? Oh, well, 4 can be rewritten as 2 squared, and 8 is 2 cubed. So that's what I'll use. I'll use 2. So we've got 2 cubed. Don't forget to bring down the x that was already there in the problem. And then 4 is 2 squared. I can set the exponents equal now. We've got 3 times x equals 2. Of course, 3 times x, that's just 3x. Now divide both sides by 3 in order to cancel that 3 there. And I've got x equals 2/3. Another one. All right, in B, I have 9 to the x plus 1 power equals 27 to the x. This is one that we kind of already looked at with the 9 and 27. If you remember, those can both be rewritten as base 3. 9 is 3 squared. Remember what I'm doing here? I'm not changing the number. I'm just changing what it looks like. Everything that I've written in parentheses should still be equal to the number we started with. 3 squared equals 9. 3 cubed equals 27. So you can always check your work. Make sure those are equal. Now that the bases are the same, I can set the exponents equal. Step 1 is going to be to multiply. So I'm going to distribute the 2 here. I'm going to multiply 3 times x. Now to solve for x, I want to get all the x's on one side. So I'm going to subtract 2x from both sides, and I get 2 equals x. Oh, and for this one, we are done. X equals 2 is our final answer. All right, in C, my bases are 3 and 81. Now 3 I can't really rewrite as anything. Nothing to a power equals 3 besides itself. So instead we're gonna have to rewrite 81 so that it's a base of 3. So 3 to the 4th power is 81. So we'll rewrite this 3 to the 4th. I'll bring down 3 to the x minus 2. Now I've got base 3 on both sides, and so we can set x minus 2 equal to 4. To solve this, I would add 2 to both sides, and I get x equals 6. All right, another one. 27 to the x equals 1/9 cubed. We've got 27, and now we've got 1/9. Okay, so 27 and 9, we've seen a few problems with these. We're going to try to rewrite them both as base 3. For 27, that's 3 cubed. Bring down the x. But now I need to get 1/9 to be 3 to a power. Okay, 2 steps here. First, I need the fraction to become a whole number. Okay, so I know that that's going to have to be a negative exponent. And then the second part, I need 3 to become 9. Well, 3 squared is 9. So 3 to the -2 power would be 1/9. Bring down that 3 from the original problem. Now I have 2 base 3's, which is good. I can set their exponents equal. We have 3 times x equals -2 times 3 is -6. All right, solve for x. I'll divide by 3 on both sides, and I get x equals -2. All right, for E here, we're going to rewrite 36 and 216 so that they're the same base. Okay, notice I keep saying base, not the same number, because it's really important you remember that when we're rewriting these, we have to rewrite them as a number to an exponent, okay? So it has to be an exponential, a base to a power. 36, I know 36 is 6 squared, So maybe 216 can also be rewritten as 6 to a power. So if you're not very comfortable with these, you can always use your calculator to try multiplying these values and see if you can get 6 to 216. And you can. So we've got 6 squared is 36, and then 6 cubed is 216. Now I've got the same base. I can ignore the bases and set the exponents equal. Solve for x, so I'll divide by 2 on both sides, and x equals 3/2. All right, in this next one, I have 32 to the 2x power equals 16 to the x plus 3. Now, I know that 16 times 2 is 32, but that doesn't help us here because remember, we have to rewrite these as a base to an exponent. So that won't work. We can try some other numbers though. I know that 2 to the 5th power is 32. Bring down the 2x. And 2 to the 4th power is 16. All right, now I can set their exponents equal. 5 times 2x equals 4 times x plus 3. Go ahead and multiply. 10x equals 4x plus 12. I'll subtract 4x from both sides to try to get the x's together. So we get 6x equals 12. Now divide by 6 in order to get x by itself, and I get x equals 2. All right, here's another problem. 4 to the 2x power equals 1/2 to the x minus 6. Rewriting these, I'm going to try to rewrite them as base of 2 because I know that 4 is 2 squared. Bring down the 2x. And then I have 1 over 2, so I just need that 2 to not be in the denominator. Again, we're going to use that negative exponent property to bring it up to the numerator. Now we can drop the bases and set the exponents equal. I get 4x equals -1 times x minus 6. Now when I distribute that -1, I'm going to get -x plus 6 by multiplying by the -1. Now I'm going to get the x's together by adding x to both sides. 5x equals 6. Finish solving for x by dividing both sides by 5, and I get x equals 6/5. All right, for h, looking at h, I've got 25 and 625. I know that 25 is 5 squared, so maybe I could use base 5. And if you choose to do that, that's totally fine. But you can also play around with 25 too. So if you try 25 squared, you actually get 625. Now, either way that you do this problem, if you don't notice that 625 is 25 squared, you'll still get the correct answer if you follow the steps correctly. But in this one, I don't have to rewrite 25 since I can rewrite 625 as 25 squared. All right, set the exponents equal. I'm going to distribute the 2 here, so 2x minus 4 equals x. I will then subtract 2x over, and I get -x equals -4. Now, even though it looks like x is alone, it does have that negative out front, which we need to cancel. So I'll just divide both sides by -1 so that those cancel, and I get x equals +4. All right, we've made it almost to the end, so we might as well do the last one as well. I've got 4 to the x minus 2 power equals 64. All right, well, 64 is 4 cubed. So I can rewrite that as 4 cubed. Now I can set the exponents equal. solve for x by adding 2 to both sides, and I get x equals 5. Again, if you're having trouble with these bases, use your calculator. Try to get comfortable with all of the common bases: 1 squared, 2 squared, 3 squared, 4 squared, 2 cubed, 3 cubed, 4 cubed, 5 cubed, and that will help you a lot as well.